Welcome. In this tutorial, we'll build a small JavaScript utility that repeatedly adds digits of a non-negative number until only one digit remains. This operation is sometimes called the digital root. It's a neat little trick that appears in puzzles and quick checksum tasks. I'll show you two clean implementations: an easy to understand iterative version, which is good for learning, and a mathematical big O1 formula, which is also fast and elegant. Let's jump in and implement both with clear input validation and friendly output. The procedure is straightforward. Sum the digits, repeat if the sum has more than one digit, and keep doing that until you end up with a single digit number from 0 to 9. We'll show a loop-based solution, which is intuitive, and then the mathematical shortcut. The digital root equals 0 if n is 0, otherwise 1 plus where n minus 1 mod 9. Both produce the same result. The formula is instant and great for large numbers. Here are two idiomatic solutions. The iterative digit sum explicitly sums digits by repeatedly extracting the last digit with modulo 10. Easy to follow and perfect for stepping through in a debugger. Digital root uses the mathematical shortcut. For positive integers, the repeated sum equals 1 plus n minus 1 modulo 9, and we use a special case where n is strictly equal to 0. This runs in big O one time, which is excellent for very large inputs. The test wrapper calls the formula by default for speed, but you can swap in iterative digit sum when you want to demonstrate the process. Validation stops nonsense early. The iterative root simulates what you need to do by hand. The formula leverages number theory, where repeated digit sums cycle every 9, which is mod 9, giving the compact expression. For example, 39, which goes into 3 plus 9 is equal to 12, which goes 1 plus 2 is equal to 3. The formula 1 plus 39 minus 1 modulo 9 is 1 plus 38 modulo 9 is equal to 1 plus 2 is equal to 3. These examples confirm both methods. For 39, the iterative steps are clear. The formula also returns 3 instantly. For 47, you get 2. Single digit inputs, like 9, are returned unchanged, and 0 is a valid input that maps to 0. Good to state explicitly for clarity. The digital root shows up in math puzzles and can serve up as a simple checksum, which are divisibility tests. It is also great for teaching examples to compare an intuitive loop-based solution with a compact mathematical trick. Use the iterative approach when you want clarity for learners, and the formula in performance-sensitive code. To wrap up, you now have a clear iterative implementation to demonstrate the repeated digit sum process, and a one-line mathematical method to compute the same result instantly. Both are useful. Pick the one that fits your needs. If you want, I can also provide a strict string input version that sums digits of a large numeric string and shows a step-by-step visual animation you can place in a video or produce a short one-line functional variant. Which would be more helpful next? Thank you for watching. If you enjoyed this video, please make sure to like, share, and subscribe for more JavaScript tutorials. I'll see you in the next one.